In section 8.3, we're looking at solving linear equations, and the form is ax plus b equals cx plus d. Here it tells us that the variable is x, that is our unknown number, and so that will stay x, but a, b, c, d, in this case, are constants or numbers. In the previous sections, the book explains how we don't always see every single problem fitting this pattern. But problems can be manipulated, moved, things can be added together and such to be able to get something similar to this form. And so it mentions here that we will be using different properties to solve this, such as the distributive property and addition principle of equality, the multiplication principle of equality, things like that. So let's make sure that we understand what they're talking about here. And so let's give an example and describe some of these things. So first thing that's mentioned is distributive property. And so what that would look like is, let's use letters also to describe this first. A parentheses B, and it could be plus or minus C, where we'll use an example of some letters and variables in a second. But no matter what the A, what the B is, or what the C is, what's on the outside next to parentheses means multiplication, and the A will get distributed or passed out to everything that's inside parentheses. So what we get would be the answer of A times B added to A times C. So for an example, if we had 3 times x plus 5, for example, what we're doing is the 3 times the x plus the 3 times the 5, which will give us just 3x plus 15 when we multiply what we can, which is the 3 times the 5. So what's on the outside of the parentheses gets multiplied to everything inside the parentheses. And again, note that there's nothing in between the 3 and the parentheses. So again, you can think of an invisible multiplication sign there. Now they mentioned the addition principle of equality, the multiplication principle of equality. We have seen those before. We just don't talk about them with those terms. And so the addition principle just basically tells us we can add, or adding the negative would be subtracting something to an equation as long as we do the same to both sides. And so an example from what we've seen with that would be maybe x minus 5 equals 12. So if we wanted to get x by itself, we need to get rid of subtracting 5 by doing the opposite, which is adding 5. And so again, since we put the plus 5 on the left, we put it on the right as well. And so when we simplify that, negative 5 and plus 5 adds to 0, so that drops, and we will get x equals 17. And then the same thing can be done with the multiplication principle of equality. So we can multiply and divide by the same thing on both sides. And so, example of a multiplication or division would be when we are solving our proportions. And so if we had, for example, 7 times x equals 28, we can multiply both sides by 1/7 if we want to think of multiplication, which is the same thing as dividing by 7. And then again, 7 divided by 7 gives us 1 there. So 1x is just x, and that equals 4. Or another example would be if we had x over 5 equals -3. Again, we can think of our fraction bar as division. So the opposite would be to multiply by 5. And so that means we would need to multiply 5 times the other side, and divide by 5, multiply by 5, cancel each other out. And we're left with 1x on the left-hand side, or just x. And -3 times 5 is -15. So those are some examples of what they're trying to describe here in these words. I know that the way they describe it can be a little intimidating, but they're really talking about some pretty simple things that you've had practice using before. So for our first example, they want us to solve the equations using these principles when necessary, and then we need to determine if we get ax plus b equals cx plus d, so variables on both sides, maybe just ax plus b equals c, so a variable plus a constant equals another constant, excuse me, whether just x plus b equals c, where there's no number, no coefficient in front of our x, or just a times x equals c, where there's no constant being added. So again, those are just different patterns that we might see where x is the letter x, the a, b, c, d's are just other numbers, whether they're attached to the x as a coefficient or being added or subtracted as a constant. And so for our first one, let's look at combining like terms, because on the left-hand side, we see an x component here and an x component here. So we're going to combine our 2x and our -3x together, and 2 minus 3 would be -1x. And again, we've mentioned before, the 1 kind of becomes invisible. We know that 1 is understood to be a multiplier to x, and so we can technically just write that as -x. And then if we look at our next part, we have a constant term of 7 being added, and then another constant term there at 5 as well. So we're going to look at combining the positive 7 and 5 together, and 7 plus 5 is 12. So I'm just bringing that down. And then we have our equal sign. And on the right-hand side of our equal sign, we have 18 subtract 18, which when we do that, we get nothing left. So we have a 0. So the pattern that we're following are -x. Remember that negative is really -1. And so if we look at it as a variable, -1 would be our first actual number. So that would be an a. The x stays the x. Here we have a number 12, so there's our second number, so we'll label that one as B. Our equal sign 0 is our third number, and so that equals our C, our third number. So we have the pattern AX plus B equals C. A represents our -1 value, B represents our 12, and C represents our 0 in this problem. Our next example, we have things to combine on both sides. So let's go for our constants first. Here we have 4, and we have -4, which we know subtracts to get us 0. And then we have plus 12x. There's nothing else to change it, so we'll keep our plus 12x. Now, if you notice, here we have 0 plus 12x. There's other things with the 12, or with the 0, the 12x. And so in this case, we don't have to write our 0. That can drop off, and we're having a positive 12x remaining, which we don't need to write a positive sign. We have just 12x. Now for our first question, if you look at that one, 0 was the only thing on the right side of the equal sign, so it had to stay. Where here, when 0 is being added to something else, it's not necessary to write that, so it can drop off. Here we have our equal sign. And we start combining like terms on this side. We come across the same thing when we have our x's that we're combining like terms together. So 3x minus 3x, or 3x plus a -3x, gives us 0 there. And then we have our plus 5 with nothing to change it. So we have plus 5 over here. And 0 plus 5 is just 5. That 0 from the 3x's disappears. And so we have 12x equals 5. So again, if we go to our pattern, the coefficient of 12 is a number, so we'll label that one as our first letter A. Our x is our unknown variable, which stays as x. And then the 5 is the second number in our problem, and so we'll give that the letter B. So this problem we have that AX equals B, although the way that they wrote that was actually AX equals C, because they're using that B on the left-hand side and the C and the D on the right-hand side. But it's still the same pattern whether I put a B there or a C. That we have a number times our unknown equals a constant. Here's our next example. Again, we have things on both sides that we are going to be combining together. So let's start by just combining our x's. This time, let's not actually write them next to each other. We have 3x plus 7x. We can do 3 plus 7, easy to get 10. And then we have 24, and we're combining it with a minus 15, so 24 minus 15, or we can think of it as 24 plus a negative 15 if we wanted to. And that's a positive 9, so we'll put plus 9 here. And that equals, we see a 10x on the left-hand side with nothing to combine it with. And then we have our negative 2. Don't forget that that minus sign in front of it has to be looked at as a negative number, negative 2. And we have 3 being added to that, so negative 2 plus 3 equals 1. So we have plus 1. Now we could solve and keep going, and you might say, but what? Oh, don't worry about that yet. We're just looking at the patterns. When we simplify the equation, we're not quite solving it yet. So in this case, we have our pattern of a number in front of our x, so our coefficient a times x, then adding a constant of b. On the right-hand side, we have another number, which is c times our x, and then we're adding a constant on that side as well. So we have that ax plus b equals cx plus d pattern, just by simplifying the left side and the right side as far as we can go. And if we look at an example here, we have -2 plus 3, which would give us a 1. And again, that 1 can disappear. We don't need it there. It's understood to be that. So we have x purple. And then we have -1 with nothing to change it. So x subtract 1 or x minus 1 equals. And then on the right-hand side, all we have is a subtraction that we can do of two constants. 52 minus 42 is 10. And so here, our 1 dropped, so we don't need anything with the x. And so we're just going to say that we have a pattern x. And even though it's a minus, we'll look at this pattern plus b. And we can think of that as adding a -1 equals c. Now you may think, then what about the other problem? Why did we put a variable in front of this question when we had a negative there and we dropped the 1? So we had -x and we put an a there even though we dropped our 1. But on the question we just did, we dropped the 1 and we didn't put a 1. Well, it's because of the negative sign. Since there's a negative there, we have to show that -1 there, and that a reminds us that there's a negative there that has to be taken care of. Where here, 1 multiplying, dividing by 1 doesn't change anything, where multiplying or dividing by -1 does. So that's why we don't need to put this as ax, where we did with the other one. Equations of the form ax plus b equals cx plus d can be created by using both the addition and multiplication principles of equality. Let's start with the equation x equals 1. Applying the addition principle by adding 9 to both sides leaves us with x plus 9 equals 10. If we use the multiplication principle by multiplying both sides by 2, notice now we have that distributive property to multiply the x plus 9 times 2, and we will get a result of 2x plus 18 equals 20. And then we can go back to the addition principle and add -4x to both sides. And when we do that and then combine like terms on the left, we get -2x plus 18 equals 20 minus 4x. We are going to now do the same thing ourselves to get an equation. And notice, since what we did on the first example was doing the same thing to both sides, we still have that identity of x equals 1. And so if we were to solve the equation that we got at the end, we would get x equals 1. Or if we plugged in 1 as for x, we would get a true statement with the same value on either side. So let's do our own now with x equals 1. So let's go ahead and add 5 to both sides. So we can simplify the right side. The left side stays x plus 5, and we get 6. Now let's use a multiplication principle, and let's multiply both sides by 4. So again, I need to put my x plus 5 expression in parentheses. And so that means we need to distribute 4 times x gives us 4x, and then 4 times 5 will be 20, so the left side simplifies down to 4x plus 20. And on the right side, we get 24. And let's go ahead and do the addition principle this time. And we will this time add, let's add 7x to both sides. Squeeze it back here, plus 7x instead of having to write it. That almost looks like a times sign, doesn't it? So plus 7x and plus 7x. So on the left-hand side now, we have our like terms. 7 plus 4 is 11. So we have 11x plus 20. And on the right side, we have 24 plus 7x. Or we can switch it and write 7x plus 24. Again, standard form usually tells us to write our pieces with our variables first and then our constants last, which it doesn't matter if you put 24 plus 7x. I would absolutely accept that. So there we created our own problem, which again, since we did the same thing to both sides, if we were to try and solve that, we would get our original statement of x equals 1. So when we're solving the problem, when we're given an equation that we need to figure out what that value of x is, we need to do some steps. First, we would simplify both sides of the equation, combining like terms, distributing if we need to get rid of parentheses. And then what we want to do is use the addition principle to get all the terms that have the variable on one side of the equation. And so the way I think of it is anything with an x or whatever your variable is goes to one side of the equation, everything else goes to the other. And then if you have a coefficient, a front number on your x, such as 3x, you need to get rid of that. It says to use the reciprocal of the coefficients. And so for the example of 3x, the reciprocal would be 1/3 because you're taking that and flipping it. And so multiplying by the reciprocal is the same thing as dividing. I think of it as it's times 3, I'm dividing by 3. And then obviously the last step is to check your answer. You can put the number that you get back into the original equation and see if you get a true statement to see if your answer checks out or if you made a mistake along the way. To solve the equation created in problem 1, we need to undo the steps that we took to build the problem. It says, however, we may not undo the steps in the order that they were used to create the problem. So we're asked to solve the equation and verify that x equals 1 is a solution. And so if we have our problem, there's not a whole lot of room here. Let me see if I can. No, it's not going to let me add space. So let's put underneath. So here's A. We don't have a whole lot of room up here. So let me try typing it. I think it will go better that way. So we have 18 minus 2x equals 20 minus 4x. So again, it's telling us that we want variables on one side of the equation. So anything with an x goes one way and anything without an x goes the other way. So if you want to, you can write it afterwards, or you can always write it underneath. Let me show you what both would look like. If I'm going to write it afterwards, let's say we want to move our x's to the left. I always like my x's to end up positive whenever possible. And so I always move the smaller amount to the larger amount. And in this case, -2 and -4, well, I'd rather owe $2 than $4. So negative 4 is actually going to be the smaller amount. But when we do the opposite, we're going to be adding 4. And so we can put plus 4x here to undo the minus 4x, which would be here, adding 4x to it as well. So that's what it would look like if we were writing our problem linearly, because in order to get rid of the negative 4x on the right and therefore move all our x's to the left, we would be adding 4x to both sides, and then we would simplify by combining like terms, which the x's on the right would simply disappear because they become 0. But what I like to do is to show underneath, because I like to work my problems up and down instead of left to right, or vertically versus horizontally. So what I like to show is that if I add 4x here, that's going to zero out because negative 4 plus 4 is 0. And so then I need to do the same thing to the other side of my equal sign. And so I'm going to line up my x's together and then add down. So we have 18 still, it doesn't change. Negative 2 plus 4 would be positive 2, so 18 plus 2x. And that equals 20. We don't have to put our 0x. That disappears because we still have something on that side, so we can just drop it off. And so now anything with an x is left. So that means anything without an x has to move right. And so we see a positive 18, so to get rid of it, we need to do the opposite of a positive, which is a negative, or subtracting 18 from both sides. So again, when I do that, 18 minus 18 is 0. So I got rid of that like I needed to, and I dropped down my positive 2x, or we just write it as 2x. We know that that's a positive number. And then 20 minus 18 is 2. So then the directions told us to multiply both sides by the reciprocal of 2, which would be 1/2. But again, I always like to think of I'm getting rid of my multiplication by doing the opposite and dividing. So what that does, instead of zeroing out, anything divided by itself gives you 1. And we know that 1 doesn't need to be written in front of x, so 1x is the same as an x without the 1 written. And then 2 divided by 2 is 1. On the right-hand side, there's nothing else, so the 1 can't disappear on the right-hand side. And so we just proved that x equals 1 in the equation that they gave us. So in the equation that we created, we had 11x plus 20 equals 7x plus 24. So again, we want to start off by all the x's going one way or the other, or you could start with a constant sign. We start with the variables. The smaller amount is the 7, so it's positive. We need to subtract 7, so we can have no x's left on this side. So again, 7 minus 7 will zero out. But in order to do that, we have to subtract 7 x's from the left-hand side as well. So 11 minus 7 leaves us with 4 x's. And we'll bring down our plus 20. We didn't do anything to change that. And that equals, our x's are now gone. So we only have 24 on the right-hand side. So now that the left-hand side is the only side that has x's, we need to get rid of the constant term of 20. It's being added, so the opposite would be to subtract it. So again, on the left-hand side, 20 minus 20 is 0. And so when we bring down our 4x, that's all we have to write. We don't have to put plus 0. And then on the right-hand side, 24 minus 20 leaves us with 4. And then our final step is getting rid of the multiplication by division. And so 4 divided by 4 will give us a single x, 1x. And so we need to divide by 4 on the right-hand side as well. So again, we see x equals 1, which is what we started out with before we added things to our original equation of x equals 1. Now, in these cases, we had one solution. And in both cases, x equals 1. That's called a conditional equation. The equation has the condition that x equals a certain number. If we tried to use any other number, the equation would not give us a true statement. We would get something that sounds crazy or untrue. And so a conditional equation has only one answer. We get x on one side, and then we get a value on the other side. It could be a decimal, it could be a fraction, but we have a number there that works, and the number could be 0. But there's other cases that happen. Sometimes it doesn't matter what we plug into x, we're going to get a true statement no matter what. And what that means is that we have what's called an identity equation. When we start moving things around, we see that we have the same value on either side, and we can continue those and keep moving things down to get the form 0 equals 0. And those are called identity equations, and that means that there's no one number that works, all numbers that work. And the solution then would be all real numbers. And the symbol for all real numbers looks like a capital R, but with 2 lines. That's a symbol that stands for all real numbers. And so instead of typing all real numbers for your answer, you can just write that symbol on a quiz or on a test, and they'll know what you're talking about. Other times, for example, we get what's called a contradiction. Nothing would work, and so we can never make it true. And when we get that, that means there is no solutions. Nothing would work. And just like the no smoking signs or no something signs, you can write no solution with that empty set symbol. And so it says the form would be a equals b, where a and b are different numbers. So we could get like 3 equals 5, which is not true. And I mentioned that, kind of hinted to that earlier in the problems when we were solving this one here, C. Notice we have 10x plus 9 equals 10x plus 1. And if we were to subtract 10x from both sides, we would get 9 equals 1. That can never happen. So this would have been one of those cases where there's no solution. No matter what number we try and choose for x, we're not going to get something that works out. We're not going to get something that gives us a true statement. So again, 3 different types of possible answers. Either one number, every number would work with all real numbers, or no number would work for no solutions. So let's take a look at this problem and see which type of problem we have, a conditional, identity, or contradiction. So we have x here, so that's the only x in the problem, so it's on the right. So we're going to leave it on the right, and we're going to get rid of the constant 7 and move that to the left. So again, we see a positive 7, we're subtracting it to get no constants there. So again, if we subtract 7 on the left to 0 that out, we have to subtract 7 on the right. But notice that that was a minus x. We can't lose that sign. Remember, there's an invisible 1 there. So that's a negative 1 that's being multiplied by x. And on the left-hand side, 5 minus 7 is negative 2. So now to get x truly by itself, we have to get rid of that negative 1 that's being multiplied. So let's divide it off. So again, negative 1 divided by negative 1 is a positive 1, which will leave us only an x on the right-hand side. But then on the left-hand side, we'll get negative 2 divided by negative 1, which is a positive 2. So we have one solution that works, x equals 2, and so that's our conditional. 2 is the only number that will give us a true statement for this question. Here's another one. And just like with the one that I mentioned a moment ago, you can probably see what the answer is going to be here, because how can 11 times a number adding 4 equal the same value of 11 times the number and then only adding 3? So if you were working a problem and you came down to having a statement like this where part of it matches with the 11x with your variable, but the constant doesn't match, I would just go ahead and say that I have a contradiction, which is no solution, but let's show that mathematically. And so what we would do is say, oh, I'm going to try and move the x's, so I need to get rid of the 11. So all my x's can go on one side, and what happens is I end up zeroing out the x's on both sides. So when I bring down my numbers, I have 4 equals 3. Not true. And so again, our answer would be no solution because it's a contradiction problem. 4 cannot equal 3. For this one, we have x plus 7 is the same amount as 2x minus 5. So let's try and work this one through. Let's get rid of our x's on the left-hand side. Again, I like to subtract the smaller amount when possible. And so minus x and minus x, knowing that again, there's an invisible 1 there when we subtract. X minus x is 0, so we're left with 7. 2 minus 1 is 1x, or again, we can drop the 1 and just say x. And we have minus 5. So now we'll add 5 to both sides. And so the 5 minus 5, or negative 5 plus 5 is what it actually says, zeroes out, and we're left with an x on the right and 12 on the left. There was no number to divide by, now our coefficient of x. And so we are done. And you can see one answer, one number is conditional. 12 is the only number that will work for this one. Here's an example where we actually have a little bit more math involved. First thing that we're going to do is get rid of our parentheses. You cannot, according to orders of operation, add first. Do not add 9 plus 3 to get 12. We have to do orders of operation, which means get rid of the parentheses first. So we're going to take that 3 and we're going to distribute it to both things that are inside of our parentheses. And so let me type this so it just becomes clear for you to read. So the x plus 9, we didn't do anything with. And then 3 times x is 3x, so we have plus 3x. And then 3 times 1 is 3. So the left-hand side, now we have x plus 9 plus 3x plus 3. And on the right side, I'm just going to copy it down. We could start combining like terms, but I like to just go ahead and take care of one idea, which in this case is distributing, before I worry about anything else. So the next thing that we're going to do is combine like terms. And so we can see that we have x, which again, we know there's an invisible 1 there, so we have 1x plus 3x on that side and 6x minus 2x on this side. And then for our constants, we have 9 plus 3 on the left. So let's work that out and see what we get. So on the right-hand side, 1x plus 3x gives us 4x, and then 9 plus 3 is 12. And on the right-hand side, we have 6x minus 2x, which leaves us 4x. And then there's nothing to change the plus 12, so we get plus 12. Now notice what we have. We have the exact same thing on both sides. And so we can stop there when we see that everything matches and say that we have an identity problem, which again, if we're going to write the solution, we would say that our solution is all real numbers, which can be written as that symbol. But if we were to prove what they said we can get down to 0 equals 0, we could subtract 4x from both sides. And when we do that, we end up zeroing both of them out. And so we're left with 12 equals 12. And then if we wanted to get down to our 0, all we would say is, now I'm going to subtract 12 from both sides. And again, once we do that, we're left with nothing on one side and nothing on the other side. So it can keep going to 0 equals 0. But for proof for me, as long as you get something, once you see that the sides match exactly, you know you have an identity situation where your answer is all real numbers. Here's a couple questions for you to try on your own now, so go ahead and pause and work these out. Check your answers in the answer key, and then you can go ahead and move forward, and we'll look at some of the story problems together. A company has two packing options for shipping quantities of a certain inventory item. Option A uses 20 boxes and there are 5 items unpacked. Option B requires more filler and uses 23 boxes, where each holds 2 less than items in option A, and there are only 3 items unpacked. The situation can be represented by 20x plus 5 equals 23 times the quantity x minus 2 plus 3, where x is the number of items that can fit in box used for option A. So 20x plus 5 represents 20 boxes and there are 5 items unpacked. And each x, remember, represents the number of items can fit in one box. So the equation 20x plus 5 represents the total number of items needed packing. The x minus 2 represents that the second option, the box holds 2 less items than the first option. So 2 items less than option A, because x, remember, is the number of items that option A's boxes hold. And so now we need to solve the equation. So again, let's copy it over here so we can solve it. And so we have 20x plus 5 equals 23 times x minus 2 and then plus 3. So again, first thing we need to do is get rid of our parentheses. So we're going to distribute 23 into the x minus 2. And so we'll have 20x plus 5, because we're not doing anything to that side yet, equals 23x. So that's 23 times x. But then we have to do 23 times minus 2 or negative 2, which will give us negative 46. And then plus 3. So now we have combining like terms to do. On the right-hand side, we have minus 46 and plus 3. So we have 20x plus 5 equals 23x minus 43. And we combine those like terms. So now let's get all our x's to one side. 20 is a smaller, so that's one I like to move. So we see positive 20, so we'll subtract 20x from both sides. And so we get that zeroing out on the left-hand side, and we're left with 5. And 23 minus 20 leaves us 3x. And we'll bring down our minus 43. So then our next step is to get the 43 gone. And so we'll add 43 to both sides. And so 43 plus 5 will give us 48. And that equals, we zeroed out the 43s, so just the 3x on the right. Now our last step is to divide both sides by 3, which leaves us x equals 16. And so that's the equation's solution. It says to check our solution. So again, we're going to plug in 16 anytime we see an x. So we'll do 20 times x, so 20 times 16 plus 5 equals 23 times x minus 2, so 16 minus 2, and then plus 3. So if we look at the left side of our equation, we would do 20 times 16, and that will give us 320, and we're adding 5 to it, so that gives us 325. And on the right-hand side, we're going to do parentheses first, so 16 minus 2 would give us 14. So then we need to do 23 times 14, which would be 232, and then 222, and then 222 plus 3 would be 325. Screwing up my numbers, sorry, 325. And so we do get that 325 equals 325. But again, interpreting C, which is the value of x, it means that the boxes in option A hold 16 items. Two advertisement flyers have the same area. The first flyer has a length of 12 inches and a width of X inches. The second flyer has a length of 4 inches and a width that is 10 inches more than X. The situation can be represented by 12X equals 4 times the quantity 10 plus X, where X is the width of the first flyer. So 12X represents the area of the first flyer because that's the length times the width. And then if we look at 10 plus x, it says that the width is 10 inches more than x in the description, so that would be the width of the second flyer. So now we're going to solve the equation. So again, let's put it over here so we have them to work with. So 12x equals 4 times 10 plus x. First step is to get rid of our parentheses. We're going to distribute that through. And so when we do that, we'll leave 12x alone on the left, and 4 times 10 is 40. And 4 times x would just be 4x. So now what we need to do is move the x's to one side. Since there's only x's on the left, it makes sense to move the 4 over. We're going to subtract 4x from both sides. So our x's are gone on the right. On the left, we have 12 minus 4 would be 8. So 8x equals 40. Our last step would be to divide the 8 off. So we're left with a single x on the left and then we need to do 40 divided by 8, which is 5. And that 5 is in inches. So we solved it for x equals 5. Now they want us to check our solution. So again, we're going to plug in 5 times anytime we see the x. So 12x means 12 times 5. And that's the same as 4 times 10 plus x, which again, x equals 5. So then when we do that, 12 times 5 is 60. And then we get 4 times 15, which is also 60. So what does our answer from part C? So that's the answer to x. What does x represent is what it's asking us. And remember, that's the width of the first fire. So our result is the width of the first fire is 5 inches. Almost done. The manager of a cafe wants to list a price for the weekly featured combo that includes tax. He wants to sell a medium house blend coffee with a pastry for a total of $5.45. He doesn't know which pastry to sell with the coffee to avoid losing money on the combo. The medium coffee costs $2.75 and the tax is 9%. He uses the equation 1.09 times 275 plus x to equal 545 to determine the price of the pastry, which is represented by the variable x. I do want to point something out here because it might be a little confusing to you where they got this 1.09. Since the sales tax is 9%, that's where the 0.09 comes from. But the one in front of it, remember, anything times 1 stays the same. And so when you multiply by 1 point and then the percentage of sales tax, it does that addition automatically for you. Remember, in previous problems, we'd find the sales tax and then add it on to the total cost. Well, doing 1.09 does that all in one step. It finds the sales tax and adds it to the total all in one step, which is nice. So the sum 275 plus x would be the cost before tax of the special, which would be the medium coffee and pastry. And so now when we solve for x, a little. So we have, and I'm not going to rewrite everything because I'm just going to show here that we need to distribute on this side. So we'll just start off with simplifying that here for part of our answer. So when we distribute 1.09 times 2.75, we get 2.9975. And then 1.09 times x will be 1.09x. And that equals our 545. So now what we need to do is to get the x by itself. So we're going to undo what's being added, the constant first, since x is already only on the left-hand side. We want to get the 2.9975 on, so we'll subtract 0.29975. Notice I'm not rounding because I don't want to screw up my answer. We want to always make sure that we're waiting to round at the very end if they tell us to round. In this case, if we actually try and round, we'll get a number that doesn't come out evenly, where leaving it alone helps us. Because when we subtract, we get 1.09x equals, and then on the right-hand side, we get 2.4525, which doesn't seem like it's getting any better for us with those decimals. But on the last step, when we divide 1.09 and 1.09, we get that x equals 225, 2.25. And again, that's a dollar amount. And so x equals $2.25. So, which of the following pastries would you choose to be a part of the combo? Explain why you made the choice. Well, in order for it to be break even, we would need 225. So, break even would be choosing the coffee cake. So if we don't want to make any money, we would choose a coffee. Losing money would be to choose a pastry that costs more than that, would be the cherry pie. And then to actually make money from it, we would choose something that's less than the 225, which would be choose the bagel. So it depends on what you're wanting. Obviously, the losing money is not what they wanted, so avoid losing money. So the cherry pie is gone. So if you only want to make money, you choose a bagel. If you want to make money or just break even, you would choose the coffee cake as well. So depending on how you want to decide for the manager, depending on which ones you choose. But again, explaining why you choose that. So again, if you're willing to break even, you would also choose a coffee cake. If not, the bagel is the way to go only. If you have any questions with this lesson, send them to me via email. Otherwise, I'll see you next time.